This video is going to give a breakdown of some example problems that are included on our 5.1 practice check. Before we get to those problems though, it is important that we go through the material presented to us in the 5.1 lesson page and watch those videos before we try to attempt our 5.1 packet. In this example, we're trying to use a graph and determine whether y is directly proportional to x. If so, we need to find the constant of proportionality and then write a direct proportion equation. We will start with number 1 and set up our y values over our x values. We should set this up as 5 over 1, 10 over 2, and 15 over 3. We then divide each y value by each corresponding x value. When you divide 5 by 1, we end up with 5. 10 divided by 2 gives us 5, and 15 divided by 3 also gives us 5. We should notice that we ended up with the same quotient for each y divided by x. Therefore, there is a constant of proportionality, and y is directly proportional to x. Our constant in this situation would be 5. We represent a constant with the letter k. So our constant would be k equals 5. The last part of this problem tells us to write a direct proportion equation. To write a direct proportion equation, we follow the format of y equals kx. K would be our constant, so we're going to replace that, and we will write it as y equals 5x. Now take a moment, pause the video, and try number 2 on your own. Once you have your y over x value set up, you could start to divide y by x. 130 divided by 2 gives us 65. 100 divided by 4 gives us 25. Because they are not the same quotients, there is no constant of proportionality in this problem. When we submit our answers for these problems, number 1 can be submitted as k equals 5, and then we could write y equals 5x. And for number 2, because there is no proportion, we could say y is not directly proportional to x. In our next set of problems, we're going to determine whether y is directly proportional to x through the use of an equation. One way of doing this is by isolating y. So our goal is going to be to get y by itself, just as we would if we were solving an equation and we wanted to isolate the variable. In these situations though, we're going to try and isolate y to get y on the left side by itself. In number 5, we're going to start by dividing both sides by 3. This will remove the coefficient from the left side. If you notice on the right side, I am multiplying by a third. Because we had 1/2 divided by 3, and when you divide by fractions, you end up multiplying by the reciprocal, I just wrote that as 1/2 times 1/3. After dividing both sides of the equation by 3, we are left with y equals 1/6 x. We should notice that this follows the format of y equals kx. When we isolate y, the right side should just be a constant times x. If it is not in the format of y equals kx, then the problem does not show a direct proportion. In this case, we should notice that it does follow the format of y equals kx, and in our constant spot is 1/6. Therefore, our constant is 1/6, and the equation 3y equals 1/2 times x is a direct proportion. You can again pause the video and try to solve number 6 on your own. For number 6, we have y on the left side, so we will start by isolating y and adding 5 to both sides of the equation. That would leave us with 2y equals x plus 5. Our next step is to divide both sides by the coefficient of 2. When we do that, we are left with y equals 1/2 x plus 5/2. We should notice that this does not follow the format of y equals kx. Therefore, this does not show a direct proportion. The last problem that we're going to look at is going to be a word problem. This problem here has a table that shows us the distance traveled, which is d miles, and the amount of gasoline used, which is represented as n gallons. It says to tell whether d is directly proportional to n. If so, give the constant of proportionality and tell what it represents in this situation. Then write a direct proportion equation. In this type of problem, we are not given a y and an x value, so we need to use the words to help us determine what our y and x values are. The line that helps us to do so is where the ratio is stated. In this problem, it is the line that says tell whether d is directly proportional to n. So in this problem, we are comparing d to n, so we would set it up as a ratio of d over n. D would represent our y value, and n would represent our x value. Take a moment to divide your d values by your corresponding n values and determine whether there is a constant or not. When we set up d over n, we should have 20 over 1, 40 over 2, and 60 over 3. When you divide your d values by your corresponding n values, you will notice that each quotient is equal to 20. Therefore, we have a constant of 20, and we could represent that as k equals 20. To put this into an equation, we are going to replace our y value and our x value with the letters d and n. And instead of using k, we will use our constant of 20. So an equation to represent this table would be written as d equals 20n. The last thing that we have to do with this problem is to determine what our constant represents. To do that, we are going to set up d over n and write out what d is and what n is. D represents miles and n represents gallons. Therefore, we are comparing miles per gallon. Because the constant is 20, we would write that as 20 over 1, and we can say that the constant represents 20 miles per gallon.